Here we have Chapter 2, Section 2, homework assignments. The first question, write the set, list the whole numbers between 0 and 4. Didn't say we can use 0 and 4, so the set we can use is 1, 2, 3. Those are the numbers between 0 and 4, which is C. Write the set indicated. List a set of states that border Maine. If you know your geography, and you see Maine is a very top hand corner of the United States, and the only state that borders it is New Hampshire. It has to be in brackets. Write the set 13, 14, 15, 16 using set builder notation. Set builder notation looks like this. The set of our variable of x, this little line means such that, and here you put the conditions, and then you close the set. That's set builder notation. So this example, when you write it this way, it's called the roster method. Now set builder notation, we'll pretty much put the formula down. 13, 14, 15, 16. So that's the set x such that these are all natural numbers, the counting numbers. Are they between 13 and 16? No, because those would be 12, 13, 14, 15. Or 14, 15. So that's not it. Is it between 12 and 17? Yes. It can't be less than 17 because that goes all down to 0. So it's got to be between 12 and 17. Number 4. Write the odd natural numbers less than 53 using set builder notation. Okay, we're looking at the set of values of x such that x odd, it's got to be odd natural numbers less than 53. So less than 52 doesn't say anything about odd, so that's not right. This doesn't say anything about odd, so it's got to be one of these two. Can we include 53? No, it said less than 53, so that's not right. So it has to be this one. X is an element of the natural numbers, and x is less than equal to 51, and is odd. So there we have it. It's got to be C. We write using math symbols. The set of A with elements Iowa and California is not equal to, that's that symbol, to the set B, elements Texas and Virginia. Iowa and California, so that has nothing to do with it. Set A is Iowa and California, so that can't be right. Texas and Virginia, so not equal to. This means it's not contained in, so it's got to be B. Number 6. Using math symbols. The set containing the elements K and X is a proper subset of that. So the set K and X is a proper subset of K, A, E, X, T. So 6 has got to be A. Write a statement that represents a relationship between the following. Set A, where X is a letter from the word garage, and B, Y is a letter from the word rage. Garage uses the letters A, E, G, R. That's A. A, E, G, R. So they're equal. Just they're repeated. We don't count the repeated ones. So 7, they're equal. Write a statement that represents the meaning of the following. M. When we talk about an empty set, a set that has nothing, we can write it as that symbol or a set that has nothing in it. You cannot write this because this means it's a set with something in it. It's not empty, it's got something in it. So if you're going to write the set notations, it can't have anything in it, or you can use just 0. So because of that, they're equal. Write a statement following relationship. So A is 6, 7, 8. B is a set of numbers between 6 and 8 inclusive. So A is a subset of B. So this can't be right because they are contained in each other. B is not a subset of A, proper subset, so it's got to be B. A is contained in or element of B. So it's the same numbers, same numbers. Write a statement for this. A, E, I, O, U, A, E, I, O, U. They're equal. Doesn't matter if the order. They have exactly the same elements, same number, so they're equal. Indicate which symbol, element, or non-element of makes the statement true. Is 0 part of the empty set? No. Empty set means it has nothing in it. 0 is something. It's a number. Is 243 an element of this set? Can I figure out an n that makes this true? So we have 3, 9, 27. 27 times 3 is 6, 81. 81 times 3 is 243. Yep, it's there. So it's an element of. It's contained in. Alright, so is it possible or not possible to set up a one-to-one correspondence between one-to-one correspondence? So it means each element of set A corresponds to one and only one element in set B, in the other set. So Monday can go to October, Tuesday is November, so, yep, so it's possible. Oh, this one here. 0 can that, 7 go with that, 7 has to go to 7. 10 goes with 10, 14, 14. Nope, 0 has nothing, but 7 can go to 7, 10, 10, 14, 14. 0 can't go to anybody, so it's not possible. Is it possible to set up one-to-one between this? An empty set and 36. Remember, empty set has nothing in it. This is a set with 36, so it's not possible. How many one-to-one correspondences are there between the sets X, Y, Z, U, V and 2, 3, 6, 7, 8? If each correspondent X must correspond to 8 and Z to 6. So X goes to 8 and Z goes to 6. So we have 3 letters each. the number of possibilities. 3 times 2. That factorial simply means take that number, multiply everything down. So if we had 5 factorial, we have 5 times 4 times 3 times 2 times 1. The reason being because with the remaining letters, y can go with 2, x, the y can go with 3, y can go with 10. So we can combine those 6 different ways. Find the cardinality of A. There's 1, 2, 3, 4, 5. The cardinality of A is 5. Okay, find the cardinality of the set A from 300 to 3000, everything. Well, remember we did something like that in chapter 1, where we had to first find how many elements do we have. We have the sum. We have to find the number of elements divided by 2 times the sum, which would be 3300. Maybe 2701 of those guys. Remember, a to the power a sub n is the first one. The difference n plus 1. So the last number is 3000. The first number is 300. The difference is 1. So subtract 300 from, so it's 2700. 1 times that, so it's n plus 1. Subtract 1. It's n minus 1. Because we have that many number of elements. So we add 1. So the number of elements we have is 2701. We're looking for the cardinality. So find the cardinality of the set A. X is a number on a clock face. It goes from 1 to 12. So it's D. Right. And that does it for that section.